Hello friends, this is Sumit Krishnan and welcoming you all back to the drone pilot training course. And now we shall be discussing the fourth chapter of the course, which is fixed wing operations and aerodynamics. In this chapter, we will discuss about what is basically a fixed wing drone, what are their various parts it is made up of, how the fixed wing drones can be classified, the structural parts, the avionics that are used to make a fixed wing drone is a part of this chapter. We shall also be looking at various terminologies which are associated with fixed wing drones, applications, and many things. So, without further delay, let's delve into this chapter and begin up with the session. So, fixed wing drone. How can we define accurately this term fixed wing drone? Because we know drones are of various types. There could be a rotorcraft drone, fixed wing drone, the VTOL, which are hybrid drones. So, when it comes to define this term fixed wing drone, a very accurate definition could be on the screen, which is it is an unmanned aircraft that derives support for its lift from aerodynamic reactions of the air on its surfaces. That is a wave which remains fixed under given conditions of flight. So we can understand from this definition that it is the wind which is here a primary source of lift in case of a fixed wing aircraft, and it derives support for its lift from the aerodynamic reactions, and those reactions are on the surface of the aircraft, and that surface is particularly a wing here. So this is very important to remember, and this wing remains fixed under the given conditions of flight. Means it never disappears. It is the only source of generation of lift. So it has to be there on base during the phase of flight. Types of fixed wing drones. Based on engine configuration, the fixed wing drones can be divided into a pusher configuration, puller or a tractor configuration, or the third one is the VTOL configuration. Let us discuss about pusher configuration. A pusher configuration fixed wing drone is a type of aircraft design where the engine is mounted behind the wing and the propeller is positioned on the engine, which could be a motor, in such a way so that it pushes the aircraft forward. This is what we can define as a pusher configuration fixed wing drone. Now, this configuration had some advantages and disadvantages. Pusher aircraft offers better camera view as there is no engine or any rotating component which is mounted in front and obstructing the view. And there is one disadvantage also which is associated with the turbulent interactions of pusher propellers result in reduced efficiency and thus performance. Now, why is it so? It can be easily understood because in pusher aircraft, we have a propeller which is mounted at the backside of the wing, and so when the air is approaching the propeller and passing through the propeller test, till it reaches, it becomes turbulent because it has to first pass on through the vehicle's front and then it will pass over the wings. So it will very uniform and flowing smoothly. Most of its energy has already been used by the wing to generate the lift. So because of the losses, now it becomes a little challenging for a propeller to develop the thrust from that turbulent air, and therefore its propulsive efficiency and also you can say the aerodynamic efficiency little bit gaps reduce. So this is the drawback. Now, puller configuration. A puller configuration fixed wing drone is a type of aircraft design where the engine is mounted in front of the wing. Okay, we can see in the image the engine is mounted at the nose and the propeller is attached to that motor or engine in such a way so that it pulls the aircraft forward. Puller aircraft tend to be more efficient than pusher aircraft. We have just discussed the drawback. So that thing is not present in case of the free stream air approaching the propeller is very uniform and ready to get converted efficiently into thrust. Okay. And cooler aircraft tend to be faster than pusher aircraft due to the reduced drag caused by the engine located in front of the X. So drag is also less compared to the pusher aircraft. Now the third type of fixed wing drone is the VTOL. That means vertical takeoff and landing fixed wing drone. Now this type of VTOL is actually a hybrid fixed wing drone. It has the ability to take off and land vertically. So it has an advantage that there is no need of any runway, and VTOL aircraft has another advantage that it can access the locations which are difficult to reach by other means of transportation. It has a speed because it flies like a fixed wing, and it can take off and land from the areas in which a fixed wing aircraft actually the conventional fixed wing could not land. So this VTOL can land like a rotorcraft, like a helicopter. Okay. VTOL aircraft also have some drawbacks attached with it because nothing comes off free. So when you are getting some benefit out of something, there are some weaknesses which are attached with it. Nothing is perfect. So VTOL aircraft have shorter range and endurance compared to a traditional fixed wing aircraft. So this is their designer compromises with VTOL. So this classification that we discussed was these types that we discussed was when we classified the fixed wing on the basis of the engine which is mounted. Now we can classify their types on the basis of the location of the wing. We can see in the figure that there is a high wing configuration which is possible. Based on the location of the wing, it can be divided into three types: high wing, mid wing, and a low wing. So the high wing, we can see in the figure that the wing is attached above the midline of the fuselage and mounted over the fuselage. In the mid wing, we can see the wing is mounted exactly at the midline of the fuselage, and in the low wing, the wings are mounted below the midline of the fuselage. Now, similar to the previous type configurations, the present configuration also have some of the advantages and disadvantages. The high wing has more ground clearance, and they are also very stable at slower speeds. This is one of the important advantage to have a high wing. There are also some disadvantages as well, which are that, however, we are not looking at those things at present. The mid wings in these airplanes offer a very high maneuverability, but they are as stable as high wing airplanes. Okay, and the low wing configuration is safer during emergency landings, and because the impact that takes place during the landing, there's a wing to share some of the shocks, and the entire shock does not transmit to the fuselage. So this is one of the safest feature of having a low wing, and also it requires shorter takeoff distance due to enhanced ground effect. When the airplane flies near the ground, when it is about to take off or about to land, and when the ground is just below the wing, and if that distance is, if wings are close to the ground, then this ground effect is active, and it helps the aircraft to develop a very high amount of lift. And because low wings are close to the ground, so ground effect is more active in this configuration, and therefore more lift during takeoff or landing. And therefore, as a result, we need a very shorter ground road distance for takeoff as well as for landing. And also, this ground effect basically reduces the induced drag of the aircraft. So you can understand it in this way. Now, types of fixed wing based on the form of the wing. The wings which are mounted over the fuselage could be of various shapes. Could be of a rectangular wing. From the top, when you will look at it, the platform may appear rectangular. So it is a rectangular wing. when it is looking as a elliptic, it is an elliptical wing. It could be a trapezoidal wing. It could be a swept back wing, and it could be a delta wing. And various others, a mix of these configurations are also possible. However, these are the major ones. We can see on the screen there are various types of wing shapes. In the first row, column, we have a first one rectangular wing, and then we have a trapezoidal elliptical swept back, the wing which is dust swept, and the wing which is more swept, and the delta wing is there. And every wing offers different aerodynamic efficiency. Aerodynamic efficiency means L by D ratio. So, like elliptical wing has a very good distribution of lift on its surface because of its shape. But there are again some better wings which are available, which may not offer very good lift distribution, but they are good to fly at higher speeds, like swept back wings or delta wings. So, depending upon the requirements and mission, the wing platforms are picked up, and every configuration will be having its own pros and cons. And a user, or I should say, a designer has to select the wing, then form with lot of care and understanding of the machine. Airframe or structural parts. There are various parts from which the entire fixed wing drone is made up of. We can see on the screen the important airframe structural parts. We have a propeller which is mounted at the nose of the fuselage, and propeller is mounted on the engine. Engine is shown here at the nose. The propeller is basically an interface between the engine and the aircraft. It changes when it converts the engine's rotational motion of the shaft into a thrust. Okay, and there is a fuselage that gives you a space for the crew, for the pilot, for the payloads, and there is a wing shown here, the primary surface responsible for generation of the lift for a fixed wing. And we can see that this wing has several control surfaces attached with it, which are shown here. Flaps and ailerons. Flaps are responsible to generate a high amount of lift during landing or takeoff, because speed is slow, and when the come speed is slow, these flaps helps the wing to generate enough amount of lift that could help the aircraft to become airborne or stays airborne. And we have an ailerons which are shown here, mounted at near the tip of the wing. The main function of the aileron is to create the rolling motion. When the aircraft wants to take a turn, a rolling is required, means banking the wing at some angle, and these ailerons are attached on the left and right side. These ailerons moves they flex in a direction opposite to one another. If one aileron will go up, the other side of the wing's aileron has to be moved down. Only then it can create the force to roll. Okay, so these are the things which are the control surfaces on the wing. Then we have a tail section which is composed of vertical stabilizer and horizontal stabilizer, means vertical tail and horizontal tail. Now, these tails are also known as stabilizers because for a stability in a fixed wing, these are the vertical and horizontal tail parts which are responsible. So, vertical stabilizers and horizontal stabilizers provides the stability to the fixed wing drone, and there are some control surfaces which are mounted on the horizontal tail of the aircraft and the vertical tail. The horizontal tail or a horizontal stabilizer has a control surface which is an elevator, and elevator is responsible for the aircraft to increase the angle of attack during takeoff and climb into the sky. So it is the elevator that allows the aircraft to pitch up or pitch down. Okay, and there is another control surface which is a rudder attached with the vertical stabilizer section of the tail, and rudder is responsible for generating the yawing motion. Okay, the directional motion of the aircraft during on the ground. This rudder pilot use this rudder patterns to change the direction of the aircraft. Okay. And during flight also, rudder is used along with ailerons in order to back. Okay. So these are the important airframe or structural parts. Airfoil nomenclature. The wing of a fixed wing aircraft has a cross section, which is a particular profile known as airfoil. Okay. This airfoil, there are several terms which are associated with the airfoil. So we must understand this, as this shall help us in designing the fixed wing drone. The airfoil has a chord line that connects the leading edge and the trailing edge of the airfoil. Okay, and airfoil are of various types. The one which is shown in the picture here is a cambered airfoil. Cambered airfoil has a camber, little camber. However, symmetrical airfoil does not has a camber. Camber is basically a curvature, we can say. Which, if you will cut the symmetric airfoil exactly in into two, it will get divided into two equal halves from the mid. However, the one which is cambered airfoil, if you will try to cut this into two equal halves, it won't, because this is, you will find that the two sections have are not symmetric. Okay, because the upper one will have more camber and the lower one will have less. And this camber helps the enhances the airfoil's capability to generate the lift. This is why camber is must, and it is appreciated and required by the designers in for their aircrafts. And we can see this can be seen here, airfoil as the side view of the wave. So when the air approaches the wave on an airfoil, you can say this relative wind has some direction, has a velocity, means direction. So when it this vector, one can easily see that this wind direction is making one angle with the chord line of the airfoil. So this angle is known as the angle of attack. Okay, alpha is a symbol which is generally used to represent angle of attack, and this angle of attack, if this angle of attack is more, the lift will be more. If angle of attack is reduced, the lift will get reduced. But there is a certain limiting value of the angle of attack. You cannot just keep on increasing it, because when you are increasing the angle of attack, you will reach a condition which is the stalling angle of attack, and after that the lift will no more be generated by the airfoil or a wing. So a pilot always takes care of it. While flying, they never go close to the stalling angle of attack during flight. Now we shall discuss about the parts of a fixed wing, but now in terms of avionics, okay, which are used to make a fixed wing drone. Okay, so we can see there is a propeller which is mounted on the shaft of a motor. Okay, and this motor is a BLDC motor. So brushless DC motor is used in this fixed wing drones construction, and BLDC motor has several advantages with it. These motors are when compared to the conventional DC motors. These brushless DC motors has a higher first weight ratio. Okay, and also it is more reliable. Okay, and long life. This is the reason, and also less maintenance is required in brushless DC motors. So this is why the such motors are preferred in fixed wing drone. Next, the motor is connected with electronic speed controller. This electronic speed controller controls the RPM of the motor. It has a sensor with it, and which identifies the location of the rotor inside this brushless DC motor. So I'm just talking about it. The brushless DC motor is a little detail. The brushless DC motor has a rotor and stator. The outer portion has the brushless DC motor, which is out of outer runner type, has a rotor outside frame rotating, has a rotating part, and inside there is a stator that has a coil, or you can poles. So this electronic speed controller identifies the location of the rotor's pole, and then it energizes the poles which are the part of the stator, and then it helps the motor to generate the torque. Okay, this is how a BLDC motor works. This electronic speed controller is, I just said, is the important component, as it is the one which is responsible for the operation of BLDC motors. Next, we have a battery which supplies power to this fixed rate draw. The one end of the AC goes to the connects with the power module, connects with the battery through a power module. You can say it. The another connection from the AC goes into the central unit, which is a flight controller here. Power module is there to regulate the voltage, and there are some other components like GPS for navigation. GPS identifies the GPS helps in navigation because it retrieves the location of the drone, and is one of the important component, okay, for safe operations. And there is a radio receiver, okay, which connects with the flight control board. Radio receiver receives the radio communication commands which are sent by the remote pilot through transmitter, and we have a radio receiver antenna attached with the radio receiver. The flight controller, which is also known as the autopilot, is attached at the center, shown here in the image. And this flight controller is actually, you can say, a brain of drone, and this is the one who receives the inputs from the remote pilot and process it. It uses the sensors to sense the orientation, movement, acceleration of the drone, and then after processing it sends the command to the motors, servos through ESC to develop the required RPM so that the tool can move. Okay, and this flight controller also helps in the stability. As telemetry is another important equipment for safe flight. Telemetry helps to connect helps you to connect your drone through a ground control station, and this connection is a wireless connection. Telemetry has antenna with it. We have some control servo motors which are attached on the wings and at the tail. These servo motors actuates the control surfaces and like ailerons, flaps, elevators, rudder, so that the drones can perform the required manually during the flight, and it helps to control the drone actually. Yes. GCS, the full form of GCS is the ground control station, and I was studying that actually these drones are a part of UAS, means unmanned aircraft systems, and unmanned aircraft systems have three important parts. One is your unmanned aircraft, okay, which is also known as remotely piloted aircraft, and then we have a ground control station, okay, and the third is the command and control that helps you connect your with your tool to a ground control station, okay. So at ground control stations, we can your laptop can be understood as a ground control station, and ground control station are based on hardware and software as it allows the UAV operators to connect with the drone and its payloads. These ground control stations also set the parameters for autonomous operations. Okay, fixed wing drone terminology. There are various terms which are associated with the fixed wing drone, and let us familiarize ourselves with each one. We have a UAS. UAS means unmanned aircraft system. I have already told about unmanned aircraft system just now. Accelerometer, it is a device that measures the acceleration of the drone and any changes in its movement. This is a part of the flight control. Okay, flight controller uses the accelerometer for the flight stabilization. AGL means above ground level, and AGL refers to any altitude which is just above the ground, okay, and immediately under the unmanned aircraft. Means, like for example, if UAV is said to be flying at 100 feet above a hill which is having a height of 45 foot, so we can say that UAV is at an AGL of 55 feet. Okay, 55 feet refers the altitude just above the ground. ATC, the full form of ATC is air traffic control, and we have already discussed about this in the third chapter. BVLOS, Full form of BVLOS is beyond visual line of sight, and BVLOS operations. In BVLOS operation, the unmanned aircraft flies beyond the pilot's line of sight, and in the BVLOS operation, it is mandatory for a pilot to remain connected with the air traffic control during the entire. It needs a special permit also. ESC is an electronic speed controller, and we have to discuss this. Flight controller, we know, a device that receives the inputs from the sensors. Sensors could be a gyroscope, accelerometer, Jeep, and then it sends the outputs to the electronic speed controllers and motors so that the drone can move as per the command by the remote pilot. Geofencing. This could be a new term for you. Geofencing term refers to restricting the movement of a drone in the defined dimensions of airspace. And this geofencing technology uses a global positioning system or a GLONASS, global navigation satellite system, to establish a virtual geographic boundary to prevent the drone from flying into specific areas. GLONASS full form is Global Navigation Satellite System, and it is a satellite-based navigation system which is developed by the Russian Federation. It is same like GPS, which was developed by the United States. Okay, GPS we already know. We can move on to gyroscope. Gyroscope is a device which is responsible for helping in the stability, in stabilizing your drone. Okay, used to measure and maintain level orientation. IMU, full form of IMU is Inertial Measurement Unit. Okay, an electronic device that uses accelerometers, gyroscopes, and sometimes magnetometers to measure and report specific force, angular rate, and magnetic field of the drone in flight. Milliampere hour has the abbreviation MAH. MAH stands for milliampere hours. It is the unit of measurement which is used to describe the energy capacity of a pen. Okay, you will find the milliampere hours written over the batteries which are used in the drones. MSL stands for mean sea level, and it refers to the altitude above the average height of the sea. NOTAM. NOTAM, the full form is Notice to Airmen. It is a kind of notice to the airmen which is given to warn the pilots, US pilots, or to warn the aircraft pilots for any possible hazards or flight restrictions along a particular flight route or at any specific location. Okay. Photogrammetry. This term refers to a method of surveying and mapping through stitching photographs together to make one large end. PIC perform is pilot in command, the person which is directly responsible for the complete drone flight operation and safety of unmanned aircraft system flight. Telemetry, we have already discussed. Okay, TFR, temporary flight restriction, stands for a temporary flight restriction. VLOS. VLOS is a visual line of sight operation in which a remote pilot flies his unmanned aircraft in his line of sight. Waypoints. Waypoints refers to a set of coordinates that defines a point in space. Waypoints are used to create a flight path for the drones. GCS stands for Ground Control Station. Already we have discussed this. Operations and maneuvers of fixed wing drones. Fixed wing drones during their flight can perform various maneuvers. Maneuvers term refers to the various aircraft motions which are possible during the flight. It can take off. Taking off is one of the maneuver which the particular aircraft is performing. Then landing is the another maneuver. Okay, straight and level flight is the another phase of flight, or refers to a particular motion of flight where aircraft is flying at a fixed altitude and with fixed velocity as well. Okay, and this particular phase of flight, you are maybe able to remember, right? It is what we call it as cruising, okay, in aviation. Then we have a climbing and descending after takeoff, or maybe when aircraft wants to climb from one altitude to the higher altitude. So it will be performing a pull-up maneuvering. Descending down means allowing it to come to the uh, lower altitudes, like taking an approach for a landing is one of the example of descending. The another maneuver which a fixed wing can perform is a banking turn. Banking turn refers to a simple flat turn, and the aircraft is trying to maintain the altitude and it is taking a turn. So in this state, the aircraft has to use the aileron and rudder to deflect itself like this, and then it can take a turn. During this particular state, the aircraft is acted upon by a centrifugal and centripetal force. Is the centripetal force acting on the aircraft towards the center of the turning circle, because every turn has a turning radius, and the centripetal force which is acting toward the center, the aircraft is able to maintain its flat turning because a centrifugal force is acting to balance it. And the lift, we can see it, and the lift also gets tilted when the aircraft lands. So the component of lift is actually act as a centripetal force. Weight is balancing the aircraft's lift, or I should say in opposite way, the lift is balancing the aircraft's weight. Okay. Hovering is possible in the case of fixed wing drone, but only when it is of the VTOL configuration. Okay. Hovering is a state of flight in which the VTOL aircraft maintains its particular location in the three-dimensional space, and in this particular state, the lift which is being generated by the propellers is exactly balancing the weight of the aircraft. That is why it is just maintaining its altitude. We shall also talk about some performance of fixed wing drones. The flight performance is determined by various factors. In case of fixed wing, aerodynamics is one of the important factor which affects the performance of the aircraft, like drone's wings shape, size and design has its own aerodynamics, and we have already discussed this, how the one is better with the another in which aspect. So this bandwidth influences the flight performance. Okay, it influences the capability of the fixed wing aircraft to, we can say, how long it could stay on air on a given battery. And there are some other performance parameters also, like range. Range is the distance that can be traversed by the fixed wing drone with respect to the ground, the horizontal distance. So for longer range, again, aerodynamics is influencing the capability of the fixed wing to glide. Depends upon the aerodynamics of the wings. If wings has a higher lift to drag ratio, can glide for a longer period of time. And there are many performance parameters which are affected by the aerodynamics. Power plant, the type of power plant which is used, electric motor or a IC engine used in the drone will affect the drone speed, the endurance, the time, maximum time for which it can stay in the air, and of course the maneuverability. The weight of the drone is, of course, in aircraft design, weight plays an important role, and it should be kept minimum to have a higher thrust to weight ratio, and it is always appreciated when the aircraft weight is kept at its minimum. Flight control softwares and electronics also affects the performance, because flight control software has a lot of sensors which are going to, depending on those values which are being sensed by the sensors, it is decided that by the flight controller. Flight control software and electronics affects the stability of the drone, and in turn it affects the performance also, and operating conditions like weather conditions such as wind speed, the wind direction, temperature and air density. These all will affect the drone's flight performance. Okay, let us discuss about the applications of fixed wing drones. The fixed wing UAVs can be used for precision agriculture, where monitoring of the crops and its growth patterns can be observed. These can also be used for fertilizer spraying, or mapping and surveying. These drones are very useful. The fixed wing drones can generate digital surface models of the terrain, and it can cover over a large areas of land which is not easily possible to survey by the conventional methods. Environmental monitoring can be done using fixed wing drones. Fixed wing drones can be used in the forest, the bird and the animal sanctuaries which are there. It can monitor the wildlife to protect it from poachers, because a lot of the tiger reserve, the wildlife sanctuaries, these all are facing the issue of poachers, means the one who hunts the animal. So there are some people who are involved in these crimes, and they are affecting the wildlife by killing the animals which are endangered species. For search and rescue operations, these fixed wing drones can play a very important role. Defense and military have been a very important area of operation. It can help the nation to operate safely, and no other outside threats can destroy the integrity of the country. A country is having drones, these fixed wing UAVs, or its surveillance at their international boundaries. Okay, it can be used for the cargo delivery, infrastructure like inspection, like roadways, airways, the airports, the seaports construction. These all have very good structures and facilities, and during the construction of such complex uh, structures, the monitoring and inspection can be done using its a fixed wing drone. It can track the progress of the, let's say, railways, railway tracks, construction, construction process. Okay, it can be used for aerial targets, which is again which is again a use of drones for defense and military purpose. Okay, every technology has advantages and disadvantages with it. So the same case here also. The first we shall discuss about the merits. The merits are long range capabilities. Fixed wing drones have a long range capability. They have long endurance. They have a very good stability. They have a very good payload capacity, lower operating costs, high altitude flying capacity. However, cons are not much, but little bit complex to operate, because a lot of skills are required in order to fly a fixed wing UAV. It's not that easy. Large tip off and landing downward distances required. Okay. So with this, I would like to thank you all to stay connected in with me in this chapter, and soon we should be covering the remaining course in the next session. Thank you, everyone.